It's a spicy pizza box.
Yes, this is a Supermicro Pizza Box server with a shiny new 32-core Emerald Rapids server CPU in it. But more importantly, I think this has something in it that is going to change the course of the industry and be disruptive. But let's take a look at the chassis that Supermicro's got going on first. To change the course of the industry and be insanely disruptive? Is that what he said? Yes. This platform features a PCI Express Intel Flex 170 GPU. I think that GPU is a little bit of a dark horse. It's got a little bit of a false start, but it's got the goods in terms of performance. But I needed a chariot to carry that Trojan horse forward in order to do some demonstrations and some projects. And in order to do that, I had to get this system from Supermicro. This is not from Intel, and it doesn't have anything to do with Intel. This is about a $5,000 configuration because I'm that insane. And I really wanted to take Flex 170 for a test drive in a context that Intel so far has not blessed, but I think will work anyway. But let's talk about the chassis. All right, so this is what's known as a short depth 1U rack mount server, and it's an airflow system where it sucks air in the front and blows air out the back, where the front is actually defined as the place where all the ports are, the power supplies, and everything else. So this is, it's not unusual to see this kind of configuration for a telecom rack or edge compute or something like that. In the AI vernacular, you might hear it's an edge server, an inferencing server, ingest server. In our case, I've configured this for with Proxmox VDI, using it as part of a cluster in mind. And so this would be a very, very compact, very high performance cluster. But again, we'll get to that. The model, this is a 515B-R8X13. At the front, you can see we've got our dual power supplies, a power button, RS-232 serial, 2 USB 2 ports, 2 USB 5 gigabit ports, our onboard LAN and onboard IPMI port, dedicated power button. There's also a dedicated grounding screw, VGA out as part of our IPMI. And then we have 2 X16 slots, which is full length, full height, and 1 half height, half length slot. Our power supplies are 80 plus platinum. They are 110 or 240 volts. And they're 800 watts each. Now, even though these are 800 watt power supplies, I did not opt for the highest end Emerald Rapids CPU configuration. This is an 8 memory channel configuration, DDR5 registered, 32 gig DIMMs. This platform is configured as 256 gigabytes with a 32 core, 64 thread Emerald Rapids CPU. As you can see, we've got a pretty good layout for our 1U fans. We've got some dedicated 1U fans just for cooling your GPU solution, which could be a single height or a double height. As this thing is configured, I've got a single slot Flex 170 GPU in here. Now with the top removed, we can see some really cool stuff about the internal layout. We've got our short depth power supplies here and power distribution system under here. Generally, that shouldn't require any maintenance. Standard ATX power connectors for our motherboard. Our motherboard's actually pretty small considering that we're rocking that high-end Sapphire Rapids socket. Full 8 memory channel support, which is great. We've also got lots of mini cool edge connectors. Each one of these is 8 PCIe Gen 5 lanes, so you could actually do some creative stuff with the internal layout here. And of course, our PCIe expansion over here. There are actually 2 X16 slots on this side, so you could run 2 Flex 170 GPUs over here and a Flex 140 GPU here, which is half height, half length. So you've got quite a bit of PCIe expansion here. Or you could run a high-speed network card plus 2 Flex 170s or some combination. The Flex 170 is passively cooled, so we've got plenty of 1U cooling here at the front edge. We've got plenty of 1U cooling for both our DDR5 memory as well as our Emerald Rapids CPU. That is the Intel 6538N 32-core CPU. It's also configured with a 205 watt TDP. So this is not, the highest end. The 800 watt power supplies are a little overkill here. And in fact, with our kilowatt, as we'll see in a minute, doesn't use anywhere near that, even under full load. You've got 2 2.5 inch bays here, which could be wired into your mini cool edge connectors. If we're using the mini cool edge to U.2 or U.3, you can have some permanently mounted U.2 or U.3 storage. It also has onboard M.2, which I'm using for the operating system drive. We've got an onboard USB port, so you could use a low profile USB stick. VMware, kind of Broadcom. engage below with your thoughts on the Broadcom thing, if and only if you are a VMware customer, and let me know what you think, because that's the thing that's happening now. This motherboard from Supermicro, if you want to take a closer look at like the actual specs and features of the motherboard, is the X13 SEW-TF. You can check out the full specs of that on Supermicro's website, but like I said, this is an ample chariot for that 4677 monster CPU from Intel. This chassis also has some hidden features. So if I just pop this out, it takes a lot of screws, but there is actually one quick release lever. For maintenance, to make maintenance a little easier. But that is our Flex 170 GPU, and again, we'll come back to that in just a second. We'll talk strategy and industry once we get through the chassis. We get the mini cool edge connector breakout, so you've got two PCB risers on this effectively, one for the two slots on this side. You can see the other slot poking out here, and the slot on this side, which is 8 lanes from this mini cool edge connector, plus the 8 that come from the actual socket interface and power delivery and everything else. 16 lanes, not bad. You can kind of see in our chassis layout here that we've got some options. There's screw holes for 2.5-inch hard drives. So if you want to use your PCIe connectivity over here and have 4 NVMe, you could in lieu of storage. If you wanted to give up your one PCIe slot on the bottom here to use 2.5 storage in conjunction with your GPU, there is physically room to do that. As configured, these Flex GPUs, they do not have their own fans. It's pass-through cooling. So you have open air cooling on the bottom and this kind of cooling on the top. I actually found better temperatures on our Flex 170 taping off this, which forced a lot more air through the Flex 170 GPU with the cooling that we have. But Supermicro has done a little bit of special sauce here because the management interface can actually detect the temperatures from the Flex 170, it seems, and will run the fans as appropriate for the Flex 170. Meaning that when I tape this off, the system is a little quieter and the Flex 170 runs a little cooler. Without the tape and the holes, the fans run a little higher, the GPU's a little warmer, but in a data center that probably doesn't matter. On my desk running benchmarks, matters a little bit. Another important consideration is your Flex 170 8-pin interface is GPU style power and not EPS 12 volt style power. A lot of GPUs use EPS 12 volt power like a CPU, not a GPU, but these really don't use a lot of power. The wattage here is pretty reasonable. In fact, here's the full spec breakdown from Intel for the Flex 170. That is an amazing chassis. Good job, Supermicro. Let's talk strategy for a second. So this is going to be the second part of this video. I've got a Flex 170 in here, and I'm going to run Linux. The Flex 170 is an officially supported project from Red Hat. That means Red Hat probably has a customer that has worked with Intel, because Intel, they don't, it's like, if you build it, they will come. That's not a thing that Intel does, really. Especially when we're talking about GPUs. It's not a knock, it's just the way that it is. So Red Hat has some amazing OpenShift plugins that are open on GitHub, and you should go check that out because you can build inferencing, you can build an OpenShift interface that will move jobs between inferencing and GPU pass-through. This thing does support SR-IOV. It supports up to 31 virtual functions. Real world, it can do 28 1080p 60 FPS 4K streams at the same time for video encoding and video delivery. And I think that a lot of the Asian market customers were using this for video game delivery, content streaming, content encoding, that sort of thing. So running multiple of these GPUs in a chassis. With 32 cores, you could reasonably give, 16 VDI clients, 2 cores, 4 cores, or 4 threads, a decent amount of memory, and a pretty big slice of this GPU, or an even bigger slice if you put 2 Flex 170s in this chassis, which it does support. I'm here with Eric from Intel.
Hello.
And we're going to take a look at Red Hat OpenShift, but Red Hat OpenShift for AI, but also how easy it is to move back and forth between CPU and GPU inferencing on the new Intel platforms. And also, it's a Flex 140 demo. I'm all about the Flex GPUs and some off-label uses of those, and it's really exciting to see them in a real-world use case sort of scenario here. So, hello.
Hello. So, I'm showing Red Hat OpenShift Data Science, and as mentioned, I've got a Flex 140 card. This card has 8 XE cores per GPU for a total of 16. That also means with 2 GPUs, you get twice as many transcoding units. Supports the AV1 video codec, which is the open source alternative to the H.265. We also have the Flex 170. Now, this isn't in my demo, but this is 32 XE cores for one single GPU. So we also support 31 virtual functions per GPU. So on this card, you get 62 versus 31 on this one. Now, shifting over to OpenShift, what I'm actually showing is our integration into Red Hat OpenShift using our Intel device plugins operator. If you look at the different installed operators on OpenShift, the IDPO is where we are running all of our upstream device plugins to expose Intel accelerators. Currently, we support Intel GPUs, the Flex series, and Intel Software Guard extensions, which is the Enclave page cache, the encrypted memory, where you can run your applications in that's been around for a few years. This will expose the memory resources. Now, within Red Hat OpenShift Data Science, I have these different OpenVINO notebooks. And if you look across, you'll see I have one that says CPU, one that says GPU. And if you scroll up just a little bit, I'll see if I can find it. It's always hard to find. To switch between running a model on CPU versus GPU is as easy as just changing this G to a C and this G to a C, recompile the model and rerun it. Now, I'm not going to run through the model, but I just ran through it so you can see there's a trailing edge of my GPU usage of one of my GPUs. There's 2 GPUs that are actually on the Flex 140. One of them ran the workload. And my CPU went up just a little bit. If I were to rerun the same workload, I'm running a 30 CPU container. You would see all 30 CPUs shoot straight to the top.
This is really, really exciting because this same kind of thing is also available in Intel's Dev Cloud that they just announced. Well, they kind of launched a long time ago, but they kind of didn't, but it's sort of getting some new stuff. Dev Cloud is where it's at from Intel to be able to play with this kind of stuff immediately, but you can also just deploy it in your own OpenShift container and on your own hardware, and you're ready to go.
Did I mention these are certified device plugins?
Oh, yeah. That does make a difference because
just want to make sure.
Nobody ever got fired for buying certified hardware.
Engagement challenge. Do you have an NVIDIA-based VDI solution in your infrastructure? NVIDIA and VMware have worked together historically for a long time, and that is subscription-based. The most popular virtual desktop software for video acceleration is actually subscription-based. But let's talk for a second about why and sort of how that came to be. When you use a remote computer through remote desktop or anything like that, it really feels completely different if you have hardware acceleration, like H.264 hardware acceleration. There are a lot of people that are running VMware Horizon or Hyper-V without hardware acceleration, or they're using CPUs for hardware acceleration. This is one of the demos that I did at Intel Innovation. Check that out.
I'm here with Landon from Intel, and we're going to talk SRIOV, virtual desktop, and the Intel Flex 140 GPUs. These are the server-side GPUs that I've mentioned in other videos. They got a pretty killer demo here. So why don't you walk us through it?
Sure. What we have here today is we have a couple of Flex 140 GPUs that are set up so that we can show the difference between what a virtual machine is like when you have it hardware accelerated versus not hardware accelerated. And then we have, we were talking about our licensing model where we don't have a per user license or a subscription. You just buy our hardware, you get it, and it works.
So it might seem crazy, but the idea here is that you put a bunch of these in a server, and this is a GPU in a server, but it's made for remote clients. There's no output or anything like that. But the reason that you do that is because you can access hardware encoding and hardware acceleration. Even if you're not playing back a movie, the visual display that is an application running on the server is sent to the client in a compressed, efficient, low latency format. And so the user experience is demonstrably better.
That's right. So this is actually running in a server that I have back in Oregon. And then we're streaming all of that in a compressed format back to these thin clients that are here with us in San Jose. So you can see over here, this is just a Chromebook that me minimize this really quick, and you can see it's in Chrome OS. And bring it back, and now we're in our Windows environment. So you could technically, be on your tablet or anything like that and just hook up whatever your input ports are, and then you use a full Windows environment.
You really notice when there's lots of latency on those connections, and you really notice when the network does something unusual. But having that much hardware server side to do the compression and do the graphics and do the rendering, You really notice it client side because the client is doing even less work. All the client has to do is decode one stream and you're good to go.
That's right. So go ahead.
This can also run on an open platform. You want to run this on Linux, under the hood, SRIOV is how this is accomplished.
That's right. So today we support, I'm actually showing this demo. It's running ES6i version 8.0.2.
VMware.
Yeah, VMware, yeah. And then we support Ubuntu as well. Yeah, so let me show you the actual demo here today. So, what I have is on the left-hand side over here, this is your traditional VM that you would have that would not have any GPU hardware acceleration. And, as Wendell, he moves the globe around, you can see it's not a super smooth experience. But when you hardware accelerate that with a Flex GPU, it's much more smooth. It's kind of what a user would expect when they're, using Google Earth on their client. And same thing over here, I've got Blender, right? So Blender, I'm going to just move this around. And this, once again, on the left here, this is not GPU accelerated. So I'm going to move the mouse around and it is doing stuff. Give it a second.
If you want to experience this for yourself, all you got to do is uninstall your graphics driver and you'll have the same experience.
Yeah. And then, on our Flex GPU, it's nice and smooth. But what's interesting, let's see if it's kind to me when I do this. Let's pull this up. You notice my CPU utilization didn't spike. But, when I did this on my CPU-only VM, you can see how my CPU utilization spiked up to 100%.
Because the CPU has to do the rendering.
Exactly. So, what does this allow you to do? Let's say I had 4 vCPUs allocated to each of my VMs. It's not a great experience for my users if it's using 100% of the CPU to do that 3D rendering. And, I'm also eating a ton of my server system resources. So if I actually add a Flex GPU in, this guy right here is only running on 2 vCPUs, and you can see the CPU utilization was still much lower. So that allows me to increase my existing VM density too. So I could even add a Flex GPU into an old server and increase my VM density and give my users a better experience than what they have today.
I would go so far as to say that if you're doing VDI in your organization today and you don't have some type of graphics acceleration, you are literally and figuratively doing it wrong.
Okay, and then the other last thing I want to show is you can hook up multiple displays. So what we have here, this is one thin client that is actually powering 4 displays. And while we're doing this, I have one video decoding here. I can start another video decoding over here. So it'll be multiple videos decoding.
The kiosk is running off of VDI. Plot twist.
Yeah. And then, I have my GPU resources down here, and I could be doing stuff in Excel as well. All of this is hardware accelerated. And it's smooth, it's good. It's a great experience.
And it's open source accessible, which is the part that's important to me.
Yeah.
One of the most important parts to me.
Yeah. And once again, there is no per user licensing or subscription on the software side, anything like that. It's just, we want you to buy the hardware.
Fully VMware certified?
It is VMware certified.
So you don't have any excuse. You could just install this in your existing VMware cluster and you're ready to go.
And so the reason that it feels janky is because the CPU is trying to juggle running your applications along with actually doing the video encoding. All of the performance optimization and all of the stuff around building a good user experience is predicated on the assumption that you have good hardware doing the video encode part of it for your virtual desktop interface, meaning that you're running a remote Windows machine or even a remote Linux machine supports this. And that remote machine is able to do its compute in one facility of the server and do its GPU encoding for the wire in another facility of the server and send that down the wire. It can work if you have the CPU do the encoding, but it doesn't work super well. And this is also a technology that gamers have come to rely on with things like Steam game streaming depends on that Hardware 264 hardware acceleration facility. If you want low latency interactive stuff, NVIDIA Shield depended on that. Stadia was built on this same kind of technology, albeit on an AMD platform, not an Intel or an NVIDIA platform. And all of that depends on the power and efficiency and low latency of hardware encoding for H.264. And these Flex 170 GPUs are H.264, and even AV1 encoding monsters, absolutely monstrous GPUs. 16 gigs of VRAM, this is really not a lot different than the A770. That's another project that I'm working on. Shh, I know. Just, shh, soon. Just, shh. But I have to let you in on a secret. If you're a gamer and you've used an NVIDIA Shield or Steam Streaming, or you have a Steam Deck and you've experienced how good that is, the Enterprise had that technology 5 years ago plus, 6-7 years ago, really. And it popped up in a lot of other different ways before all of this. Microsoft even latched onto it and they called it Remote FX because it was such a different experience with their own remote desktop product that they said, we have to brand this something else because it is dramatically way better in terms of an end user experience. Microsoft was so worried about this that they changed some of the terms of their licensing because they were worried that they would lose Windows licenses and end user licenses because the experience of using a remote computer was so good. There's other advantages of using a remote computer in terms of intellectual property too. If you run an accounting firm, or you run an architecture firm where somebody was stealing your blueprints, or chemical engineering where somebody could steal chemical formulas, you can force people to remote into a remote machine and do their work. And so all of their work is localized. It's a lot harder for information to walk out of the building through a USB stick or through other capture when you're just displaying the machine remotely. Heck, there have even been burglaries where people have broken into offices for the sole purpose of stealing the computers in order to get the intellectual property on them. When you compute remotely, if the remote computing experience is as good or better than a local computing experience, it's a lot easier to protect those kind of assets. And so all of these companies were so worried about losing revenue stream that they sort of preemptively killed it with software licensing and everything else. So engagement challenge. Do you have an NVIDIA solution, or do you pay a subscription for virtual desktop infrastructure? Arguably, NVIDIA was the first to latch onto this and, first mover advantage. They got a lot of market share. And so not only did they get a lot of market share, they captured it for the people that were willing to pay the premiums, law offices and architecture firms and chemical engineering, things where the value of the knowledge that they have captured is so very high. It's a lot easier from an information technology management perspective to just manage a few servers for a few dozens or hundreds of people than it is to manage individual workstations and keep an eye on them. You never know when you got to protect from the employees as well. So what does all that have to do with Supermicro? This machine with this Flex 170 doesn't require a subscription. This is the first really earnest machine that I think stands a chance of disrupting and supplanting NVIDIA's chokehold on all of the virtual desktop infrastructure. I think if you had a better end user experience, a lot of you folks out there would be very keen to have a machine in your basement that your whole family could remote into for basically everything except gaming that would deliver an incredibly amazing experience. You don't need a Sapphire Rapids CPU to do that, but having as much horsepower as you have in a Flex 170, or even an unlocked NVIDIA GPU. Yeah, there's software out there that'll unlock NVIDIA gaming GPUs, older ones, for this same sort of virtual desktop use case. NVIDIA's never offered a home license or a hobby license or anything like that for this kind of stuff. But here is a solution that is full enterprise, fully qualified, ready to buy from Supermicro. This came configured as is from Supermicro with the Flex 170 and everything else. It is an officially supported hardware solution. The thing that's missing is the software stack. There's not anything fully qualified for Proxmox. That's what I'm working on. But I want to hear from you. If you use a VDI type solution in your enterprise, I want to know. Let me know in the comments or hit me up on the Level 1 forums. Do you use hardware acceleration? Meaning, do you have a GPU or GPUs in your server in order to be able to do video acceleration? You may not. You may use VDI without it. It's not a great experience, but it can work. If you use VDI with a GPU, you can have accelerated CAD. Like you can run AutoCAD and Revit and all that sort of stuff remotely, but still have a 60 FPS experience on your local terminal, and all that lovely intellectual property is protected. That's possible. But my next video is to take this for a test drive in Proxmox. Everybody is so excited about this. Even the Proxmox devs are excited about this, and they're on board, and they want to remote in and take a look. The good news is that a lot of the work that Intel's team has done, the engineers, I talked to them about this at Innovation. Most of the hard work is done in terms of the kernel and the plumbing and everything else, thanks to Red Hat and OpenShift. But this is not a project that Intel wants to take on internally. They want their partners to take up this kind of a task. Well, Dell's not going to do it, obviously, because that competes with VMware, even though things are, they might be on the out and out, with the whole small business VMware. And I think small businesses are just not interested in VMware at all for some reason at this point. Like, that's weird, isn't it? Why wouldn't they be interested in VMware? Gosh, that's a whole other video. But, yeah, they're not interested in VMware. And Proxmox and XCP-ng are way, way, way not the same level of maturity as VMware. But in a lot of ways, they'll get the job done. And in a lot of ways, getting the job done is why Linux took over the universe. In the beginning, there was Cisco and other networking companies, and the Linux solution wasn't as good. And then the next day, Linux was everywhere, completely supplanting everything. And you had crazy stuff happen, like the Open Compute Foundation mandating that Dell and HP provide hardware switches that will run open operating systems because they didn't want to get vendor lock-in. Just crazy stuff like that. That's going to happen with VDI. And so NVIDIA doesn't care about it either. I mean, they care a little bit because they make money hand over fist, but they're also making money hand over fist with AI. And so the NVIDIA empire is threatened by this if, and only if, the software aspect of this comes together and Proxmox and Linux and the needle is threaded. If those things aren't here, then the Flex 170 won't succeed. And I think there's a lot of uncertainty around Intel as well, because Intel has not, I mean, this is a card that's been available in the Asian market since 2022. It is actually genuinely very good. But I don't know that Intel internally is equipped to think about this in terms of an open source based market disruptor. But this is poised to be something that would be insanely disruptive in that VDI space. And if you work in VDI or you have a lot of experience, tell me why or why not in the comments. Like, I would like to do a follow-up video to go into this a little bit more and talk about it. But also, I want to demo Proxmox running on this thing with SRIOV pass-through, running like 16 Windows clients with full video acceleration, like 4K 60 remote over the wire. I think we can do it with this platform, and that's what I'm working on right now. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums. This is also a nice Supermicro platform. If you just want to run Red Hat OpenShift and a cluster with the Flex 170, this is plug and play. But let's try the Proxmox off-label, getting creative with the software thing first. All right, I'm signing out. You can find me in the forums. I'll see you there.